In this module, I will discuss legislation that is commonly referred to as the Clean Water Act. The purpose of this legislation is to provide protection for surface waters and groundwater. We would like our waters to be both fishable and swimmable. In this course, as we cover the Clean Water Act and then later the Clean Air Act, we're going to discuss two types of water pollution and air pollution control standards. The first type is referred to as an ambient or environmental standard. This standard specifies the concentration in water or air that must not be exceeded, regardless of the source. The idea is that we should be able to go anywhere inside the United States of America and encounter water and air that has a base quality to it. The second type of standard is described as an effluent or an emission standard, or sometimes a discharge standard. This is the standard or the maximum concentration or mass pollution that a specific source can contribute. Sometimes this standard is not discussed as a numeric criteria, but rather a degree of treatment that is required. The Clean Water Act's official name is the Federal Water Pollution Control Act. Although it was first passed in 1948, its current form began in 1972 after the EPA was established and amendments were made. This legislation is commonly known as the Clean Water Act, or Section 303. Literally, Section 303 of the Federal Code is where the Clean Water Act is written. The main objective is to restore and maintain the chemical, physical, and biological integrity of the nation's waters. The Clean Water Act, or the FWPCA, includes 4 major initiatives. We'll go through each of these in brief. For national ambient standards, there are 2 major goals. The first is to provide fishable and swimmable waters wherever these are attainable. Again, this covers both the ecological and the human health. The second was to provide or to eliminate the discharge of pollutants into navigable waters. This has been termed the zero discharge of pollutants. Pollution, in this case, was not meant to mean flow, but rather to describe the concentration at which no adverse effects are observed. And no adverse effects would include both ecological effects and human health effects. No adverse effects occur when pollution is discharged to a water body below the assimilative capacity of the water body. Any given water body can assimilate pollution or pollutant load and have zero impact. And that zero impact was what this language was intended to be. It was never intended to be zero flow, but rather zero pollution or zero negative effect. This language has been clarified, and in amendments, a new term has been used called anti-degradation. Okay, so states were required to establish designated uses for water bodies within their jurisdictions and set either numerical or narrative water quality standards for those waters according to the designated use. Examples of numerical criteria for pathogens would be that a maximum coliform count, and that would be written in number of MPN or number of CFU, are allowed per 100 milliliters of volume. We will return to this in the environmental microbiology lesson plan that is next. But the numerical criteria is a concentration that should not be exceeded. A narrative standard may be written such as waters must be free from certain undesirable discharges, or, quote, no toxics should be discharged. It's important for states to establish designated uses because water quality standards will vary for the designated use. And this is because risk varies with use. For instance, in this river with several tributaries, in one section of the river, you have 4 uses that have been defined. Warm water aquatic life, WWAL, agricultural water supply, industrial water supply, and secondary contact recreation. This would include boating. In this part of the river, though, you have primary contact recreation, which includes swimming. And then if you look down here at this third example, you have a public water supply, and so you have drinking water. With each of these uses, you have different routes of exposure and therefore different risk. And so when a state sets water quality standards, they set them according to use, which gives you the relationship to exposure, frequency, and duration. Let's look at the Kansas standards for E. coli. E. coli is the measure of pathogens or pathogen indicators. Here you have the use according to primary contact recreation and secondary contact recreation, and you have colony forming units, CFU, per 100 ml. This is the concentration term of E. coli. For each of the uses, you have both a seasonal, April to October, and November to March concentration that varies seasonally and then by use. For class, I've asked you to print the table of numeric criteria and bring it so that we can discuss certain aspects of this more in depth. Now, in the Clean Water Act, if a national water body has been sampled and it's found that the concentration of any constituent is higher than the water quality standard, then the state is required to list the water body as impaired. Impaired waters are defined as those that do not meet the national water quality standard. The list of impaired water bodies is officially referred to as the 303D list, or Section D of 303 of the Federal Code. It is updated every 4 years. When a water body is listed, the state is required to establish total maximum daily loads for that water body. The state has to determine the source of the pollution and then allocate loads to each source. And the unit for load is mass per time. This process is pretty complicated because simply studying all of the sources of pollution can be fairly time intensive. In class, we'll go to this website, but you're welcome to go there now too. This is the official list of all of the impaired water bodies in the nation. And this changes every 4 years, but currently Kansas has 1,330 impaired water bodies. So the second of the 4 major initiatives of the Clean Water Act was to set technology-based effluent limits. All publicly owned treatment works, and so POTWs refers to wastewater treatment plants. All wastewater treatment plants were required to perform secondary treatment to remove biological oxygen demand, BOD, and suspended solids, SS. Secondary treatment is defined as the use of biological treatment to reduce BOD of waste before entering a receiving water body. In Lesson Plan 9 and 10, we will be discussing BOD intensively. As we move into the discussion of wastewater treatment, you'll learn that biological treatment is the critical step for secondary treatment. For non-POTWs, or industrial discharges, the Clean Water Act said that the best practical treatment should be instituted by 1977, and that the best available treatment should be instituted by 1983. That was about a decade from when this was first enacted. I will tell you that this was a large burden to industry and was loosened in amendments. The cost analysis was too great for BAT installation. The third section of the Clean Water Act established the mechanism by which effluent standards would be propagated. This is known as the National Pollutant Discharge and Elimination System, or NPDES. This is a permit system for every point source discharger of wastewater into the environment. It initially ignored stormwater, but that has been added in amendments. So currently NPDES follows wastewater and some stormwater. The NPDES permit outlines the established treatment or required treatment and also the required monitoring that must be reported to the state. You've been asked to read a wastewater treatment NPDES permit, and we'll be discussing that in class. The fourth section of the Clean Water Act establishes federal authority. That said, states hold the initial primacy and control of the water bodies. Federal government is only allowed to step in if the states are not complying. As with all environmental legislation, there have been several amendments that have been passed. In 1976, the courts were bogged down with lawsuits, mainly from industry focused on the BAT requirement that had been put into place. The Congress then renewed the Clean Water Act, but also lessened the requirements for BAT. BAT is currently only required for toxic substances. These are listed on the EPA's priority pollutant list. It was initially 61 pollutants and now hovers around 127. These are considered the most toxic pollutants, and therefore the cost-benefit of requiring best available technology is considered acceptable. With this amendment, Congress also said industries were not required to pre-treat waste as long as the publicly owned treatment work was willing to take the waste and treat it in the municipal plant. This has been commonly used in the United States as a way to also attract industry to cities. If municipalities are willing to treat waste for you, that is a huge boon to industry. Following with lessening the best available technology requirement, conventional pollutants such as BOD, suspended solids, pH, coliforms are a pathogen indicator that we'll discuss in the next lesson plan, oil and grease. These are considered the conventional pollutants. These only require best conventional pollutant control technology, and that is defined as secondary biological treatment. The exception to this are POTWs that discharge to the ocean. These POTWs may be granted an NPDES permit with lesser treatment required than secondary treatment. And the only logical reason to this is that the assimilative capacity of the ocean is large. This is not a given exception to the rule, however. In the 1977 amendment, the EPA was also directed to promulgate best management practices, or BMPs. And BMPs were to control runoff, spills, and accidental releases of toxic substances into the environment. The spirit of this was to begin to prevent some non-point source pollution. In 1987, the amendments to the Clean Water Act were renewed and strengthened with respect to the 303D list. Because there are so many impaired water bodies, states are now required to issue a priority ranking of the list so that they can begin to try to clean up the most polluted water bodies. The second strengthening aspect of this are that the NPDES permits were expanded, specifically with regards to anti-degradation policy and stormwater. The 1987 anti-degradation policy states that existing uses of water should be maintained and protected. However, within the original use that was determined, water quality may deteriorate to a level that still maintains that use. This 1987 amendment also defined outstanding natural resource waters. We won't go into this aspect of the rule too much, but I will say that there are Tier 1 waters, Tier 2 waters, and Tier 3 waters. And the Clean Water Act now says that there is some degradation that is allowed for each of these. But the highest level of maintenance, or zero anti-degradation that is allowed, is for national park waters and any other water body that has been determined as an outstanding natural resource water. The last part of the Clean Water Act that has been passed is the expansion of the NPDES permit. NPDES permits were already required for any industry or publicly owned treatment work or any point source discharger. Phase 1 NPDES also expanded this to include any municipal storm sewer system that serves over 100,000 people. Prior to this, stormwater systems that were not combined with sewer systems can overflow directly to receiving water bodies without any discharge criteria. And in 1999, Phase 2 began, which said that any smaller municipality should begin to have an NPDES permit for their stormwater and construction projects, more than 1 acre. And so this really intersects with construction management, and you should understand that construction sites are now considered point source dischargers under this ruling. Although Phase 2 has been in the register for over a decade, states are still just beginning to issue NPDES permits for stormwater systems. So that is all of the Clean Water Act that we're going to cover in this course.